At a school party, Maria opened a soda can. She heard a fizzy sound of gas escaping from the can, even though the drink itself did not spill out. This made Maria wonder why gases spread so quickly, unlike liquids and solids. It turns out that gases behave differently because of their molecular properties. In this video, we will take a closer look at the movement of gas molecules that gives gases their special properties. Unlike solids and liquids, whose molecules are either tightly packed together or arranged in clusters, gas molecules are located far away from each other. This is because gases have very weak intermolecular forces. Intermolecular forces are the forces of attraction that exist between molecules, attracting them to each other. As gas molecules are weakly attracted to one another, they can move around freely in any direction. That's why when Maria opened the soda can, carbon dioxide gas escaped into the air quickly. The gas was present in the can at a high concentration. However, when it was released into the surroundings, it traveled to a region where its concentration was low. This movement of gas molecules from a region of high concentration to a region of low concentration is called diffusion. But what if the space for gas molecules to move around is so narrow that only one molecule can escape at a time? This results in the effusion of gases. Effusion is when gas molecules escape one after the other through a narrow opening without colliding against each other. What would happen if there was no opening or hole for a gas to escape from? This was exactly the situation before Maria opened the can. The molecules of carbon dioxide were colliding with each other and with the surface of the can, which created pressure. Pressure is a force that molecules exert on the surface of a container per unit area. It is measured in pascals. Similarly, atmospheric pressure is the pressure that air molecules exert on the surface of the earth and everything on it. Since there are large spaces between gas molecules, what would happen if we applied pressure on the gas? The molecules would be forced to come closer to one another, reducing the amount of space occupied by the gas. Therefore, the volume of the gas would decrease. Compressibility is when the volume of gases decreases as pressure is applied on them. We know that by applying or releasing pressure, gases can compress or expand. Does this also happen with changing temperature? Of course. When the temperature of a gas is increased, its molecules move further apart. Therefore, the density of gases is not constant because their volumes can change. Density is the mass per unit volume of a substance. The amount of gas molecules packed into any space gives the density of that gas. If there is a large amount of gas packed into a small space, its density is considered high. If a smaller number of molecules are packed in the same space, its density is considered low. The density of gases changes with changes in pressure and temperature. Let's review the different properties of gases that we just learned. Diffusion. Gas particles move or diffuse from a region of high concentration to a region of low concentration. Effusion. If the space through which molecules diffuse is so narrow that only one molecule can escape at a time, the gases will effuse. Pressure. When gas molecules collide with one another and the walls of their container, they exert pressure. Compressibility. Gases are compressible and mobile because they have weak intermolecular forces. Density. The volume and density of gases change with changes in temperature and pressure.